morning, and I will present about hydraulic. My team members and I will present, and my group member consists of Ahmad Shauki, Izzat Irfan, and me as Akmaluddin bin Nurain, Dafina Imani, and Anis Shafika.
Assalamualaikum warahmatullahi wabarakatuh. My name is Dafina Imani binti Ibrahim. So today I will explain about introduction of our project. Stormwater or rainwater is carried to ponds, lakes, streams, and rivers by a network of buildings, channels, and underground pipeline. They are both public and private systems in the network. It is a crucial component of the county's system for managing the amount, quality, timing, and distribution of storm runoff. So stormwater that is not absorbed by the ground due to impermeable pavement or hard surface spill over the road or hard surface is collected by the underground drainage system. So stormwater in metropolitan areas drains to smaller pipes that join to larger stormwater pipe, which is in turn connect two oversized streams or pipeline that carry the water to the water's final destination, which may be streams, creeks, rivers, or even the ocean. So this is the study area for our project that has been stated in the project instruction, which is at Taman University Parit Raja Batu Pahat. So the existing drainage exists by the main road approximately 491 meters long and has a depth of 1.8 meters and 6 meters wide, while the average slope along the drain is 2 meters. So just now we just see the study area of this project. Okay, the problem statement of this case is a drainage system was not designed properly to mitigate the floods and heavy from overspill the road, and size of the flow channel also not suitable for the area and need to be analyzed precisely in designing the stormwater drainage system. Okay, so the objective of this project is to propose a suitable drainage system that may effectively reduce the heavy flow. The second one is to establish the best type and size of drain system for the Taman University Parit Raja drainage system. And the last one is to analyze how the water flows through the drain along proposed drainage at the Taman University Parit Raja.
Hi, my name is Akmaluddin bin Nurain, and I will talk about methodology. Which methodology we use? The first step we use is site survey, which is we survey to the area and find the landscape of the area and from the slope, the size of the design. Then we goes to rational method. From rational method, we need to find the peak flow, which is Q, and to find them, we need to use Google Earth to search for the area of the catchment and the area for water to flow into the design place. And we need to use Google Urban Stormwater Management Manual, which is to find the calculation for the peak flow, and we need to use them because they have step by step, which is the accurate data, which is slow and such as thing. Then we proceed to the designing the
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Shauki bin Roslan, number battery DF210064. So I will continue our presentation on the analysis part. So in this study, we have conducted a survey to obtain several important information that maybe we can include in our report. So this picture show that activity of measuring the width and depth of the drainage, and also to make inspection of the direction flow of drainage. So based on our inspection, the water in drainage is flow from Bank Rakyat to McDonald. Next, for drainage area, we just choose a catchment area randomly, but it is nearby or close to the study drainage area. So to get the total area, the application that we use in this part is Google Earth Pro. So this is our proposed catchment area. So the total area of watershed is 107,959 meters square, which is 10.796 hectare. Next, total length and elevation of drainage. In this part also use Google Earth Pro. So the total length of drainage we got from Google Earth Pro is 490 meter, while the elevation of drainage in range 8 meter to 10 meter. So I think that's all from me. Thank you.
Alright, next, for the analysis, as we calculate from the real channel size, we got the top width is 5 meter, the depth is 2 meter, and the bottom width is 4.5 meters. Okay, for the N value, roughness coefficient, we have 0.035 because the channel is grass drain. The A area is 18 meter square. The value P, which is wetted perimeter, is 8.5 meter, and R, which is hydraulic radius, is 2.1176 meter. For the S, which is slope, we have 0.041 meter. For the TD, which is drain flow, the value is same as D, which is storm duration D. The value is 0.045 hour. Next, for T value, the average recurrency interval is 100 because the type of development is commercial and business. So we got 100. For the value I, which is rainfall intensity, we got 454.771 millimeter per hour. The value of lambda, okay, K, theta, and N, we refer on the table chapter 2, appendix 2B or 2B.1 in MSMA, where our channel refer to store JPS Batu Pahat Johor. The lambda is 64.199, the K 0.174, theta 0.201, and the N value is 0.826. As we know that the land use of this channel is commercial and business, right? So the R, which is runoff coefficient, is 0.95. Okay, last but not least, for peak flow for this channel, we get 12.956 meters square per second. Next, for the purpose new design of channel, we change the value of top width and the depth, which is 6 meter and 3 meter respectively. The value of top button are still same, which is 4.5 meter. Because of the channel is grass drain that small than 150 millimeter, the value of roughness coefficient, which is N, is also 0.035. The area is 27 meter square. Z value is 1.5. Wetted perimeter is 10.5 meter, and for hydraulic radius is 2.5714 meter. The value of D is same like TD, and we get the value is 0.0396 hour. Next, for the slope is 0.041, same as the original channel. Okay, for T value, which is the average recurrency interval, is 100 because the type of development is also commercial and business. The value of lambda, K, theta, and N we refer on the table chapter 2, appendix 2B and or 2B.1, in MSMA, and it is same as value that just now I said, where our channel refer to store JPS Batu Pahat Johor. Okay, the lambda is 6 4.199, K 0.174, theta 0.201, and the N value is 0.826. This channel is commercial and business, so the R value, which is runoff coefficient value, is 0.95. Okay, lastly, for the peak flow for this new purpose channel, which is our Q design, we get a little bit larger from the original channel, which is 13.2 meter cube per second.
From the discussion, the flow design of the discharge found to be higher than flow speed of the discharge, which means that the proposed new design of the channel sections is fast. As you can see the table below, there are few changes that we took note of, as it will help to ensure the risk of the flood. In terms of dimensions, the length and depth elongates by 1 meter to contain and store more water during rainy seasons and flow easily without any risk of clogging. In conclusion, hydraulic is a diverse field that play vital role in society, especially in civil engineering, in order to develop water resource infrastructure so that negative impact in the environment will be insignificant. In the case of this project, flood has become common occurring in every city, especially during monsoon season. At the project site, it shows that the drainage has more area underneath and it is too shallow, which causes the water flow irregularly, especially during rainy season, where the rainwater produces excessively. So, in order to prevent the flood in this area, the dimensions of the drainage must be larger than it used to be. This will to ensure that it can be stored excessive water efficiently. So, that's all from us. Thank you.